shifted. Okay, so this angle here would be equal to the angle here, alternating angles. Please, are we okay? So that is why when we look at this boundary, the angle of incidence becomes R, same as this angle. Okay, hence sine R over sine R prime. Class, are we okay?
No, please. Over.
So this is air, this is water, this is glass. The third boundary is the glass. And then now the angle of incidence in air, because it is coming from air to glass, it will be deviated towards the normal. So towards the normal. This is I, this is R. It gets to the interface between water and glass, which is here, and there will be another refraction. Okay, we are calling this as R prime. Let's say this is R prime. Now, when the ray gets to the interface between glass to air, it will deviate away from the normal. Okay, now, when the ray of light, okay, as it enters the water medium, because from here to here, okay, we have the same medium water, earth part will never be deviated. So this angle of refraction in the water becomes equal to this angle. So if this is R, this will also be R because they will alternate. Okay. If this is angle R, it will be equal to this angle because it's within the same boundary, so they will alternate. So that's how come if I'm looking for the refractive index at this boundary 2, it is equal to sine R over sine R prime. Please, are we okay? Are we okay?
Yes, please.
Good. Now let's look at the third boundary. The same thing also happens here. So long as from here to here remains glass, the angle here would alternate with the angle here. So if this is R prime, this will also be R prime. So if you are looking at the refractive index at that boundary, which is the refractive index from glass to air, it will be equal to sine R prime over. Now, you see, at this boundary, the light is coming out of the glass and entering the air medium. And it will take, once these are parallel plates, okay, this side edges are parallel, okay, because refraction at parallel plates, this angle of incidence will be the same as this angle of emergence. So if the angle of incidence within the air medium is maybe 30, when it is coming out of that multiple refraction of media, it will come out of the media through the same angle 30. So for refraction on parallel plates, angle of incidence is equal to angle of emergence. So I is equal to E. For refraction for multiple refraction occurring on parallel plates or parallel media, the angle of incidence is equal to the angle of emergence. So if it is hitting the interface by an angle theta, it will leave the number of plates or media aligned parallel through an angle of 30. Akofala?
Nsedia, please, I want to be sure if I understand the R and the R prime like correctly.
Okay.
Yes, if I'm correctly. So please, from the air to the water, there is of refraction R.
Yes.
And Yes, and from the principle of alternating angles, the angle of incidence for the ray in the water will be the same as the angle of refraction.
So the angle of incidence over here will be the same as the angle of refraction here. That's
Okay.
correct. Because within
Mm.
over here is the same medium. So this will alternate with this. So if this is R, this will also be R. Okay. Now this is R prime. Now this R prime will be the same as this R prime. But because these three media are parallel, okay, angle of incidence will certainly be equal to angle of emergence E. So if I'm looking at the refraction over here, sine R prime over sine, this is E, but it's equal to I, so I. Please,
So,
are we okay?
Mr. Dia, please, R is definitely not the same as R prime.
Come again.
R is certainly not equal to R prime.
No, this is R. Don't forget that this R will not be equal to R prime because the deviation is towards the normal, so it will reduce.
Yes, please.
Okay. All right.
Yes,
So
please.
let's multiply.
Please, can you explain the last part?
The last part is that we are looking at the deviation at this, the third deviation at the boundary. The third deviation at the boundary. Okay. So the refractive index from glass to air, N of glass to air, is equal to sine of R prime over sine of, this is E, but this E is equal to I because these are parallel media aligned together, parallel composite media. Okay, so if this is 30 degrees, this will be 30, 40, 40 because they are the three media are aligned parallel. So what is entering is what is leaving. So E is equal to I. Okay, that's why we are using this as I, not E. So when we multiply them, when we multiply all the refractive indices at the boundary, the deviation at the boundary, we have mu of A W times mu of WJ times mu of JA. This must be equal to sine I over sine R times sine R over sine R prime times sine R prime over sine I. And look at what will happen. This will cancel this. This will cancel this. And this will cancel this. So it also obeys the same thing that for three, okay, media arranged in that parallel form, the product of the refractive indices at the boundary, AW by WG by JA is equal to 1. Okay, same as when we had 2.
Mysteria.
So, hello.
Please, when you were doing the two, I wasn't here, but I understand this one. But I want you to I was wondering if you could repeat the statements where you said the product of the index and the index, that statement.
The index of the product of the refractive indices. Okay, for refraction at the three boundaries 1, 2, 3. Okay, must be equal to 1, and we've just proved it. Is that part?
Yes, please. Thank you.
Okay, meaning that supposing we have 3 media. Now we are not calling it water, glass, and air, But all that we are doing is that the first, this is 1, 2, 3. And you see, it will come out through this one, but this first medium is the same as this one. So in effect, we have 3, not 4. 1, 2, 3. Are we okay? From what we've done, it means that the refractive index of 2 with respect to 1 times the refractive index of, okay, here we are looking at the refraction over here. Refractive index of 3 with respect to 2 times the refractive index of, it is coming out from 3 to 1. 1 with respect to 3, the product must be equal to 1. Are we okay? Are we okay?
Yes, please.
So the light is actually coming from the first medium, normal, normal, normal. So when you hit, that's why I said it should follow the order, either increasing or decreasing. So the refractive index of the light is entering into the second medium, okay, through the first one. So mu of 2 through 1, when it comes here, it will be deviated towards the normal, because 3 is denser than this. We are also seeing this to be deviated towards it. So refractive index of the light is from this one, 2 entering 3. So 3 through 2. Then when we come here, it is from 3 coming out of 1. So mu of 1 with respect to 3. So when you multiply all this, the product must be equal to 1. Let's solve a question. We've done a lot. Let's use the concept, okay, to solve a problem. And I'm reading a problem. So please get ready to pen it down for me. Are we ready? Are we ready?
Yes, please.
Okay. Question 1. A light ray of wavelength. A light ray of wavelength 589 nanometer. A light ray of wavelength 589 nanometer traveling in air.
Please, 589.
589 nanometer traveling through air is incident on a smooth crown glass. On a smooth crown glass at an angle of 30 degrees to the normal. So it's incident on a smooth crown glass at an angle of 30 degrees to the normal. Find the angle of refraction. Find the angle of refraction if the refractive index of the crown glass, is 1.52. Find the angle of refraction if the refractive index of the ground glass is 1.52.
Say that please, I'm lost. Can you repeat it again?
A light ray of wavelength 589 nanometer traveling through air is incident on a smooth crown glass at an angle of 30 degrees to the normal.
Please say there.
Right. Hello. At an angle of 30 degrees to the normal. Are we there? Fine.
Say there, please. I got lost.
A beam, a light ray of wavelength 589 nanometer traveling through air is incident on a smooth crown glass at an angle of 30 degrees to the normal. At an angle of 30 degrees to the normal. Find the angle of refraction. Find the angle of refraction if the refractive index of the ground glass is 1.52. If the find the angle of refraction if the refractive index of the ground glass is 1.52. Then II. If the light ray, hello,
Saja,
hello,
you said if the refractive index of the
ground glass is 1.52.
okay.
Then II. If the light ray moves from inside the glass, if the light ray moves from inside the glass toward the glass air interface. If the light ray moves from inside the glass toward the glass air interface at an angle of 30 degrees, to the normal, at an angle of 30 degrees to the normal, what is the angle of refraction? If the light ray moves from inside the glass toward the glass air interface or glass air boundary at an angle of 30 degrees to the normal, what is the angle of refraction? Okay, so take a bite. Let's see what you can produce, okay, within maybe 6 minutes. Okay.
Say there.
Within, hello.
Please, very, very sorry. Can you please repeat II?
Can I please?
Repeat II.
Okay. II. If the light ray moves from inside the glass toward the glass air interface, at an angle of 30 degrees to the normal, what is the angle of refraction? Okay. What did you get it?
Thank you. Yes, please.
Okay, so 6 minutes. I'll attend to you in 6 minutes time. So start work. So let's look at the first question. So the light of wavelength 580 nanometer traveling from through air is incident on a smooth flat slab of crown glass at an angle of, so air to glass, and it is incidented at an angle of 30 degrees to the normal. So if this is our normal, this hits the interface at 30 to the normal. Find the angle of refraction if the refractive index of the crown glass is 1.52. So this is so simple. Once this is air to glass, it will deviate towards the normal, and we are to determine this. So Snell's law, N is equal to sine I on sine R, and we are to determine the angle of refraction, meaning we are making sine R the subject. So we have sine I over N. Okay. So sine R is equal to sine 30 degrees over the refractive index of the crown. This is the absolute refractive index. And this is the reason why the value is greater than 1. Okay. So divide by 1.52. Sine 30 is 0.5 over 1.52. So find this ratio, then determine the sine inverse of that. So R is equal to the sine inverse of 0.5 over 1.52. Okay. And this must give you 19.2 degrees as the angle of refraction, telling you that because it's traveling from air to glass, it will deviate towards the normal, and so this angle will be less than this angle. Please let me see by hands those of you who got it right. If you got it right, let's raise up your hand. Okay. All right. Then the second question. If the light ray moves from inside the glass toward the glass air boundary at an angle of, so it is now coming out of the glass. Okay. It is now coming out of the glass and at an angle of incidence of 30 degrees. Ideally, we expect that this angle must be equal to this, but they are giving us their own values. So if now the angle of incidence within the glass is 30, what will be the angle of refraction? That's all that they are looking for. Okay. That's all that they are looking for. And this time, look at the path. It is now from glass to air. Okay. It is now from glass to air. So you have to find the refractive index of air with respect to glass. Okay. The refractive index of whose hand is up? If you have a if you have a hurry up. If you have any question. Okay, so because it is coming from glass to air, you have to find this, the reverse. And don't forget, the refractive index from glass to air is always equal to 1 over the refractive index from air to glass. So because we have this, which is 1.52, we more or less have 1 over 1.52 is equal to sine of what they gave us 30 degrees divided by sine of R we are to determine outside here. Please, are we okay? Are we okay?
Can you explain it again?
Okay, in the I question, the question demands that the light is coming from glass towards this the glass air interface. What then will be the angle of refraction? What then will be the angle of refraction? And I said in the normal refraction at parallel plates, okay, we expect if once this is R, this must also be R. Once this is 30, we expect this to also be 30. But they have given us their own value, so we have to work according to it. Okay, meaning that we need to get the refractive index, okay, from glass to air. We need to determine the refractive index from glass to air, N of glass to air. But we know that the refractive index from glass to air is equal to 1 over the refractive index from air to glass. Are we okay? And we have this. So this from glass to air will be 1 on what we have as 1.52. Okay. So getting this, we can now determine the refractive index, which is glass to air, is equal to sine of I they gave us to be 30 divided by sine of R we are looking for. Okay.
Yes, please.
So all that I'm saying is that we know this, which is 1 over 1.52 over sine of I, which is 0.5, sine of 30, 0.5 divided by sine R. Therefore, sine R will be equal to 0.5 times 1.52. Put this together for me. 0.5 times 1.52.
.76.
And find the sine inverse of it. Let's see.
.49.46.
So R is equal to 49.46. Okay, so 5 degrees. And that's exactly what they got. Exactly, approximately 49.5 is what the book also had. Quickly, let's look at the question 2. Okay. Let's look at the question 2. Do I clean the board? Our time is almost up. That's why I'm.
No, please.
Copy question 2.
I gave this question.
Please, is this the solution for the II?
Yes, the II. Please be snappy with the writing. Are we through? Hello, are we through?
Mr.
Yes.
Yes.
I have a question.
Quick.
Yeah, okay, please. What if we use the refractive index of the glass with respect to the to the air to find the wavelength of um the light in the crown glass. Then we'll come and use that to find the
Yes, that would also work because
okay.
we're given wavelength and we have the refractive index of it. So you can also use the wavelength approach. Okay. All right, let me bring it. So we look at this question and you go to bed. Let's look at what was provided in the question. Refractive index of glass with respect to water. So mu of glass with respect to water is given as 9/8. Refractive index of glass with respect to air. Mu of glass with respect to air is given as 3/2. Find the refractive index of water with respect to air. You are looking for the refractive index of water with respect to air, meaning the absolute refractive index of air is what we are looking for. Okay. Let me check if our number is intact. Now, I told you that this thing must be orderly. The orderliness is that